On the day the Space Shuttle was retired, NASA's veteran engineers wept. Not from reluctance, but they clearly knew that humans had a space capability, which dropped to zero from then on. What was it? To capture a 12-ton dead satellite, pull it inside to fix it, and personally release it back. The shuttle's cargo bay was 18 m long, enough to fit a transit bus inside. Where crew drive? With 7 people, it is hard to turn around. One is a heavy-duty truck in space. If you ask a taxi to do a truck stop, doors cannot open wide. So it is not whether Crew Dragon is capable, but rather that, after the Space Shuttle was grounded, some things nothing can do anymore. So, this void fulfills it. To answer this question, we must see what machine it is. The Space Shuttle actually was. Many think it was just an oversized manned spacecraft. They wrong. Its full name is the Space Trans System. Notice not a spacecraft, a system. In essence, it was a flying space truck. The entire orbiter was 37 meters long, with a 24-meter wingspan. Its size matched an Airbus A320 airliner. Inside its alley was a huge cargo bay, 18 meters long and 4.6 meters wide. It could send to orbit nearly 25 tons of payload. What does it mean? It is like 16 car sedans into space simultaneously. The insane part is not what it sent up. Rather, it brought things back. The only ship in history to do so, capable of bringing large cargo completely back to Earth from space. Its return payload is up to 14.4 tons. This feature, up to this day, no other spacecraft in the world can match. Look at Crew Dragon. SpaceX's Crew Dragon has a total capsule height of only 4.5 meters, a 4-meter diameter, and a pressurized volume of 9.3 cubic meters, roughly the size of a small bedroom. It normally seats 4 people, with a limit of 7. But if you stuff 7 inside, they sit face to face in Dragon. Max cargo it can send is 6 tons, but actual payload delivered is only 3.3 tons. It returns less, at most 2.5 tons. When you put these numbers together versus the shuttle, the gap is not a class. It is an entire order. But if you think the difference is only a matter of carrying more or less cargo, you still underestimate the shuttle. What truly makes it irreplaceable is functions. The shuttle is equipped with a 15-meter-long robotic arm called Canadarm. It has shoulder joints and 6 DOFs, making it as flexible as a real human arm. Over 30 years, this arm did 90 space missions without a single malfunction. Never. It caught sats, deployed the Move space station modules, and helped astronauts move in space, and even retrieve a space telescope. Weighing over a dozen tons directly from orbit, put it in the bay, and release it after repairs. Can you guess this telescope? It changed our view of the universe, the Hubble Space Telescope. The story of Hubble is perhaps the most legendary chapter of the Space Shuttle. In 1990, NASA spent $1 billion to send Hubble into space. Astronomers worldwide were eagerly waiting, expecting the clearest photos from deep space. Yet when first images came, they were all blurry. It was like looking blurred. A complete blur. Checking the reason, scientists went mad. Hubble's main mirror was polished wrong. Off by how much? Less than 1/50th of a hair strand. Just this tiny error turned a precision instrument worth over $1 billion into the most expensive piece of scrap metal in space. The whole world was mocking NASA, saying you sent a blind telescope into space. But NASA did not quit. In December 1993, Shuttle Endeavour carried 7 astronauts into space. Using the arm, they grabbed at orbit and dragged it into the cargo bay. Then, wearing extravehicular spacesuits, the astronauts conducted 5 spacewalks. Working in teams, by turns, they worked in space for more than 35 hours in total, installing a corrective optics system for Hubble. It is like putting glasses on Hubble for a nearsighted telescope. Fixed, Hubble quickly saw the world clearly, captured clear deep space views of the universe and human history. Without the shuttle's large bay and arm, Hubble would be just junk. Scrap metal floating in space in 1990, and our space knowledge delayed by 20 years. Could Crew Dragon do this? No, it cannot even reach Hubble's hatch. As for the space station, the ISS is the largest space structure ever built by humanity. Its total weight exceeds 420 tons, with a length of 109 meters, roughly the size of a football field. How was this behemoth put together? The shuttle hauled it up piece by piece. The assembly took 36 flights, Space Shuttle flight missions, each time a module or truss structure weighing over 10 tons stuffed in the 18-ton cargo bay, flown to a 400 kilometers high orbit, then pieced together using a robotic arm. Think of this process as playing with building blocks in space, except each block is as large as a city bus. Plus, docking at high speed of 28,000 kilometers per hour. A million errors add. This kind of work, only the shuttle could do it. As for Dragon, it cannot even fit one truss segment of the ISS. Speaking of, some think I am bashing Crew Dragon, but I am not. To be fair, Crew Dragon does an excellent job in its own lane. First to safety. Out of 135 space shuttle flights, 2 fatal accidents occurred. Challenger and Columbia. 14 astronauts died, averaging 1 failure every 67 flights. Each time going to space, death risk was 15,000 times higher than bungee. Even more brutal, the space shuttle had no launch escape system at all. If the rocket failed, astronauts had no way to escape. When Challenger exploded 73 seconds later, the 7 astronauts had no chance to survive. Crew Dragon is different. Embedded in the sides of its spacecraft are 8 Super Draco engines. Once a rocket anomaly is detected, it can eject the whole ship in 0.5 s capsule away from the rocket, carrying them from danger. It is made to save lives, which the shuttle lacked. Then the cost. The cost of each space shuttle launch, adjusted for inflation, was about $1.5 billion to $1.75 billion. The entire 30-year program burned through over $210 billion. At Crew Dragon, each seat is about $55 million. A standard mission carries 4 people, with a cost around $400 million. Less than 1/4 of the shuttle. Furthermore, Crew Dragon's capsule is reusable. And Falcon 9's first stage booster can also be recovered and reflown, driving costs down further. So on safety and cost saving, Crew Dragon beats the shuttle. This is clear. But the question, does saving cash mean it can replace it? Not all. Things the shuttle did that Crew Dragon cannot, at least 4. First, it has no large bay, so it cannot send heavy tools, space station modules into space. Second, it has no arm, so it cannot capture, fix, or release sats. Third, cannot return big cargo, intact from space to Earth. Fourth, it has no EVA platform, so it cannot support spacewalks, like repairing Hubble. These 4 tasks are all specialties of the Space Shuttle. Yet Crew Dragon can do none. So the question is, who will take over later? For now, the most likely answer is SpaceX's other big guy, Starship. Starship is 9 m wide and a height of over 50 meters. Its cargo bay is 3 times the Shuttle S. If fully reusable, its designed payload capacity exceeds 100 tons, and could even reach over 150 tons, making the Space Shuttle S-25 tons look like pocket change. One of Starship's goals is to have all the servicing skills of the shuttle, including repairing satellites in space. But Starship is still in the testing phase. Though it finished test flights, it still has a long way to go before crew missions. Back to the first question from a tech view. Can Crew Dragon replace the Space Shuttle? It is clear, no. Crew Dragon only replaces 1/5 of Shuttle-S functions, to safely send people up and bring them back. Nothing more. It has been over 15 years since the shuttle retired. The capability gap left is partly filled by Crew Dragon and cargo spacecraft, but most remains empty. Humanity has capability to move heavy objects, repair equipment, and build large structures in space experienced a fracture on the day. The shuttle landed last, and this break has not healed today. Perhaps Starship can fill this gap in the future, but until that day comes, it is the most versatile craft humanity has ever built, bar none.